Okay, here we are with another sample for response question. In this video, I want to go over this sample FRQ, which has to do with creating a class called NumberCube right here. It only has one method called toss, and it returns an integer value between 1 and 6 inclusive, meaning it could include 1 and it could include 6. And it's going to be a random value, so we do need to use some sort of random generator, and we've gone over one in class, and it's the one I'm going to be using here. Now this itself is not part of the actual FRQ. You're supposed to assume that this works as intended. What you are supposed to code is a method called getCube_tosses. Notice that it's not within a class, and so for the purposes of this video, I'll put it in a separate class and I'll code it. That's implementation A, and then finally implementation B is to get longest run. Now, if you haven't, take a minute to read the actual FRQ and see what you're being asked to do. That's what I suggest that you do when you're taking the APCSA. Read the problem first in its entirety, and then start trying to brainstorm and problem solve this. There's two methods, right? getCube_tosses and getLongestRun. getCube_tosses requires two inputs: a cube that is an object of the NumberCube, and an integer which stands for number of tosses, num_tosses. And it returns an array of integers, not an array list. It is a public method that is also a static method, which is convenient for us because we'll be able to code the main method and then just simply call this method. And then we also have this getLongestRun, which returns an integer value, a single integer value, and it expects an array of integers that is stored in the variable values. Once again, it's also a public method that is also a static method. It being static, both of these, means that they can be referenced from the main method because the main method is also a static method. So you don't have to make a separate class to test. The values, as far as this getLongestRun, values is an array of integers. Values representing a series of NumberCube tosses, so you can read that. A precondition is that the length of values is greater than 0, meaning you can assume that you're always going to have at least more than one, or at least one toss. So its length is going to be 1. It returns -1 depending on the condition, so on and so forth. I'm not going to go into detail because I might have to leave this for a following video, but let's go ahead and start here with first coding this. The NumberCube class. Now, if you haven't already, take a moment to code this. The only thing that toss does, toss, notice that it has no parameters. So there's no variables within parentheses. That means it's expecting no inputs. Toss returns a random value between 1 and 6 inclusive. I recall a few weeks back when we first started working on these videos, there was a lot of questions on what inclusive meant. That means that you can it's going to be a random value between 1 and 6. Inclusive means including 1 and 6, and so it could be any number that is between 1 and 6 including 1 and 6. Because it's possible that it says non-inclusive, and that would mean that numbers between 1 and 6 not including 1 or 6. And so all we have to do here is do a return statement. Now let's remember how we do this. Math.random. If I just simply return math.random, so there's this class called math, and it has a method called random, static method called random, and it spits out, and I'll write it here as a comment, it spits out a double between 0 and 1, non-inclusive of 1. Which means that as is, random would be basically a decimal value. It could be like 0.001 or 0.05 or 0.5, 0.9. And because it's a double, it's going to be a very lengthy number. Now itself right here, I could compile hopefully and have no errors. And I do actually. And it has to do with the incompatible types. Math.random returns a double. Where I have it right here, double. And I've specified the return type here of this toss method. It returns an integer. Remember that right here we can either put void if there is no return or the data type of what we're returning. So I'm supposed to return an integer and this returns a double, which means we need a typecast. So we need to do some typecasting. Recall that if we typecast something like 9.5, which is, you can treat it as a double, it's a numeric value that has a decimal value. Typecasting it would be done by putting int within parentheses in front, like that. You're not multiplying it by an int, it's just you're typecasting it. So the output of this would be 9. Because when you typecast double, which this could be, it just basically ignores anything after the decimal and it gives you back an integer. And so right here, if I typecast math.random, I'll get that. There's a problem right here, which is that because this number is never going to be 1, and so it's always going to be 0 point something, and I'll put here, for example, I'll just put here i.e. So suppose that returns the random number 0.5. Well, typecasting 0.5 to an integer gives you 0. But let's suppose that instead of 0.5, the random value is 0.75. Well, typecasting that still gives you 0. Or let's suppose that it's 0.999. Remember, it's never going to be 1, non-inclusive of 1. Never. Well, that's still, if you typecast 0.999 and on and so forth, again, it ignores anything after the decimal, so it's still 0. And so right here, I'm always going to return 0. Now, let's say that I want the biggest number that comes out of here, I want it to be a 6. And so if I multiply this, and I'm going to put this in parentheses, in its own parentheses, like that. If I say, take math.random and multiply it by 6 times math.random. Well, now things have changed a little bit, because if I multiply this times 6 times math.random, what's the biggest value that you could get? Well, again, this is never going to be 1. And so you're never going to get 6. At most, you can think of getting something like 5.99999. And if you typecast that, it's 5. So once again, putting a 6 here doesn't quite return a value of 6 at maximum. However, suppose that math.random is something like let's see, what's good? 0.1, 0.1. 0.1 times 6 is 0.6. Which you typecast, it forgets anything after the decimal, so it's 0. And so right here, this effectively returns, and let me just kind of get rid of some of this right here. It returns a random value between 0 and 5. And it's not what you want. You want a random number between 1 and 6. However, you start noticing that to make 0 the lowest number, which is 0, a 1, I just need to add 1. And to make the biggest number of 5 a 6, I just need to add 1. Meaning if I take these two bounds, a number from 0 to 5, whatever the number is, any number between 0 and 5, and I add 1 to that, any number between 0 and 5, I add 1, then my new bounds are going to be a number between 1 and 6, which is actually what I'm after, right? I want a number between 1 and 6. Now, this is not a minus sign, okay? Don't think of this as a minus sign. I'm saying at the lowest, I'll get a 0. And if I take that 0 and I add 1, my lowest number, my smallest number I could get out of here is a 1. At the highest, my biggest number is a 5, and that's from this operation. And if I take that maximum value of 5 and add a 1, then my biggest number I can get out of here is 6. And so you're going to take all this after you've typecasted it. So you take math.random times 6 and then typecast to an integer, and you're going to add a 1 like that. And let me compile here and make sure that there's no conversion loss. And that's basically all there is to this method. You don't have to actually implement this. However, you need to know how it works. And so this is what it returns. Now that works, let's actually look at part A of this problem, which starts right here. Part A. Write the method getCubeTosses that takes a number cube. That's this parameter. Cube is a number cube, and a number of tosses as a parameter, which is numTosses right here. The method should return an array of the values produced by tossing the number cube the given number of times. So, for example, say somebody sends a cube, some cube, and they say they send a 3 here for numTosses. You would then execute the toss method for that cube 3 times, and every time you might get a different value. Now that translates to something like this. Okay, let me come in here. I made a separate class called NumCube tester, and I'm gonna code both of these two methods for part A and part B in here. And I know that cube is a number cube. And so if I go to the NumberCube class, every number cube has a toss method, and it returns a random number between 1 and 6, including 1 and 6. And so, for example, if I came in here and I said something like cube.toss, which I can do that because cube is a number cube, and any number cube has a toss method. I would get back a random number, a random integer, like that. This random number would be a random number between 1 and 6. But what I want to do is I want to basically perform this operation more than once, possibly more than once, at least once, and that's determined by this value, numTosses. So if somebody, well, I guess let me take it as, like, suppose the numTosses is 3, then you would make another there we go. And let me just put here, and let's not waste too much time. So let me copy this, and I'm going to put here random 2. Okay. Suppose this is 3. Well, you would want to toss the cube 3 times. Here's your cube. So here you tossed it once, and then you tossed it again, and then you tossed it again. And you want to store the value in a variable random, random1, random2. Now that's not exactly what you want, but I want you to understand how you're using the two parameters. This one tells you how many times to toss the cube. In this case, 3 is the example I'm going with. And this is the actual cube that has a toss method that you would implement like so, just like that. Cube.toss, because it's a number cube, remember? Now we don't want to store each toss, because there's 3, in a separate variable. What we want to do is we want to store the tosses in an array. And if you don't recall how to make arrays, let me remind you. You make an array of integers, which you do by giving the data type and then using the square brackets, and then you give the array a name. So in this case, I'll call it tosses, because again, there's going to store the number, all the different values that you get from tossing the number cube, and then you don't know what values, because I could do it something like this, where I store the first element in my array as such, and I'll write it so you can see. So if num tosses is 3, I want tosses to have 3 elements, and here's the first one. It's going to be a random number between 1 and 6, right? That's what toss returns. So maybe this is a 5, and then you toss again. So maybe now you get a 3 back, and then you toss again, and maybe now you get a 4. But we don't know how many elements tosses is going to have. Well, I guess we don't know how to pre-fill this. Well, we actually do know how many elements it's going to have. And so rather than hard coding the array, I'm going to use the other method the other means by which we can initialize or declare an array. And we say new int, and then in square brackets, we specify how many elements are going to be in the array. And that just happens to be that. If num tosses is 3, I want 3 elements in my array. If num tosses is 5, I want 5 elements. Okay, so now we've made the array. That's what we're going to return at the end. And now we need to populate the array. So I'll write here a comment here. We're declaring tosses array of integers with size or length, whatever you want to call it, num tosses. Now we want to actually populate the array, or initialize, if you will. And what we mean by that is we want to store an element at each location. And so we're going to use the for loop for that. We cannot use a for each. So we can't use a for each because we're trying to store values in tosses. The for each loop only works best when you're trying to retrieve values. And so we're actually trying to put numbers in the array. We will use the for loop that we're used to, int I equals 0. I is less than. Now I have 2 things that I can make I less than. I can make it equal less than num tosses, or I can make it less than tosses.length. Either way works because they're the same value, and then I'm going to increment by 1. Finally, I'll say that the element at tosses of I is going to equal cube.toss, whatever you get from that, with the understanding that I is a variable that's changing, and so if I is 0, tosses of 0 is cube.toss, which is a random number between 1 and 6, and then tosses of 1 is cube.toss again, which should give you a random number, and then so on and so forth. Now the best way to test this is to code this. Well, I guess I shouldn't say code it. I should say to write a main method. Now right here I'm returning an integer, and so to avoid compilation error, I'm just going to temporarily put return -1 like that and compile. And now we're good. Now the reason I said that it's convenient that this is a static method and that this is a static method is because when you have methods like get cube tosses and get longest run that are declared as static methods, then they can be referenced or executed from the main method, because the main method is also a static method, meaning I can do the following. Like that. The main method is also a static method. It also public. It returns nothing. Its name is main, and it can expect an array of strings called args, which we haven't gone over in class as much, and you won't have to do in the actual AP exam. Now, what's true is that you can execute a static method from within another static method. And so main is a static method. That means I can execute get tosses as such. Get cube tosses equals. Oh, not equals. Like that. Remember that tosses requires two things: a number cube and the number of tosses. That means I need to instantiate or create an instance of a number cube, and we do this like so: number cube, and you can call it whatever you want. It doesn't make a difference. I'll call it C, or maybe die or dice, like that, right? Equals new number cube. There is no constructor that is specified, and so I just use what I call a zero argument constructor, meaning I don't send any arguments because there's no constructor that I can send arguments to. And so this creates an instance of a number cube, also known as creating a NumberCube object. If you haven't looked through my tutorials on class structure, so that we can remind ourselves what this is doing right now. So the reason I need to create a NumberCube object, a die or a dice, I don't feel comfortable. I'm not even sure if I'll just call it C. The reason I need to create a number cube is because I need to get cube tosses, which is right here, I need to send it a number cube. And so right here, my first argument would be C, which is a number cube, right? The next argument is gonna be stored in this parameter, num tosses, which is an integer. And so here's where I specify how many times I want to toss the cube. I'll put here something like 5. And if I compile, I should get no error. But if I run, I won't see anything. Now, the reason I don't see anything is because when I executed the method getCubeTosses and I send it a number cube, C is a number cube, and I send it a 5, this number cube C is stored in the variable cube right here in the method, and then the 5 is stored in numTosses, and then all this happens. You create an array tosses, which is going to have 5 elements, and then start I at 0. You go until I is less than 5, and so I would be the last value of I would be 4. And basically you do tosses of 0 equals a random number, tosses of 1, tosses of 2, all the way up to tosses of 4 is some random number, and then you return tosses. And what do we mean by returning tosses? Well, we return it right here because this is where we called or we executed the getCubeTosses. And so it's returned here, but we don't do anything with it. And so what we need to do here is we need to create an array called something like, I don't know, answer equals, meaning whatever getCubeTosses returns, it returns an array of integers. I want to store it in this variable here so that I can print it. And if I print, I'm going to print it like this. I can use a for each loop here. For each integer x in answers or answer, I want to print, and I'm not going to print on a new line, so I'm not going to put ln like that. I want to print x plus a space so that when I put the next value, it puts it just a distance from it. Remember that when we only have one line of code inside a for loop, we do not need the curly braces. And right here, what I'm doing is I'm printing my result. I'm printing the answer, right? And so let me write a comment here that answer is an array of integers that is returned by getCube tosses when I send it C and the number 5. And right here, I'm using a for each loop to print every integer int in, I'll put every integer x in answer. So for each loop, which means that x is every integer in answer. Answer is the array of integers that you get when you execute get tosses or get cube tosses. Now if I compile and I run, I should see 5 different values that are all numbers between 1 and 6. There you go, you see? Perfect. Now if we increment the number of tosses, again, this second argument is stored in this second parameter. The comment tells you that the first value is going to be stored in the NumberCube, so that's C. C is also NumberCube. And so if I increment this to like maybe 10, and I run, notice how now I've tossed the cube 10 times. And you see here a run right here, 6. That's a run, which has to do with part B of this problem. That's when you get the two of the same number more than once in consecutive manner, meaning right after another. So 6, 6, and then the next run that I see is 5, 5. In theory, I would think that if the higher the number of tosses, the more runs that you'll be able to see. So let's increase this to 20. And identify the number. A run here is a run. Here's another run. Here's another run. Here's another run, and I believe that's it. Thus far, all of the runs have been no more than 2 values, consecutive values, and so let me run it again. Here we go. Okay, here's a run with 3 values, with 3 of the same values, basically 3 2s, and then here's a run where I got 3 and then a 3 right after that. And let me run it again. This is also supposed to be random, so it's supposed to get different values each time. Notice that no value exceeds the number 6, and that no value is less than the number 1. Okay, we're at 28 minutes. I just want to check the time right here.